Hello students, this is a video for class 9 chapter 5 Introduction to Euclid's Geometry. Euclid, a Greek mathematician, father of geometry. He is known as the father of geometry. Introduced the method of providing mathematical results by using deductive logical reasoning and the previously proved results. The geometry of plane figures is known as Euclidean geometry. So this is the introduction part. Students should know there is introduction to Euclid's geometry. In this part, what we are going to study. This is the starting of geometry. Now there are several terms which we are going to explain. Axiom. What is axiom? The assumptions used throughout in the mathematics and not specifically to geometry, which are obvious universal, truths are termed as axioms, and for the axioms no proofs are needed. Some of the axioms given by Euclid are as under. Now what is that? Number 1, things which are equal to same thing. Things which are equal to same thing are equal to one another. That is, if A is equal to C and B is equal to C, then A is equal to B. So this is called axiom. For this, no proof is needed. Similarly, for the second axiom, if two equals are added to equals, the wholes are equal. Actually, these are also called the basic concepts. There is, if M is equal to N and O is equal to P, then M plus O is equal to N plus P. We also can write this one. If M is equal to N and if we are adding P to both sides, there is M plus P and N plus P, they will also be equal. Because if equals are added to equals, wholes are equal. That is, M is equal to N, then P is added to both, that is M plus P is equal to N plus P. Now the third axiom. Now what is the third axiom? What is the third axiom? If equals are subtracted from equals, the remainders are equal. That is, if m is equal to n, then if we are subtracting equal terms p from both, the remainders are also equal. That is, if m is equal to n, then m minus p is equal to n minus p. Now fourth one, the things which coincide with one another are equal. The things which coincide with one another are equal. If you are two things, suppose you have two books, and if two books are such that there is one book exactly coincide on the other book, then size of the two books are equal. So this is also the basic concept. Fifth, the whole is greater than the part. That is, if m is equal to n plus p, then n is a part of m and p is also a part of m. So m must be greater than n and m must be greater than p. For example, suppose 10 is equal to 3 plus 7, then 10 is greater than 3, 10 is greater than 7. Now postulates. Now what are called postulates? Postulates, the assumptions specific to geometry which are obvious universal truths are termed as postulates. So postulates are also universal truth. Postulates are also universal truths, and these are specific to geometry. These are well understood for universal truths. These assumptions are called the postulates. Some postulates are like this: one and only one straight line can be drawn from any one point A to any other point B. It means there are 2 points A and B. So through 2 points A and B, through 2 points A and B, through 2 points A and B, we can draw only one specific line. Only one line is possible to draw. Second, postulates. What is the second postulate? A terminated line can be produced indefinitely. That is, PQ is a terminated line. That is, PQ is the line segment. Terminated line is also called line segment. So PQ is a line segment. Now the line PQ can be produced in the direction PQ and can also be produced in the direction QP infinitely. This can be produced to infinity. This also can be produced to infinity to this side. Okay. Now there is third postulates. A circle can be drawn with any center and any radius. If you want to draw a circle here, you can do this. Take this one as the center and with any radius you can draw the circle. So a circle can be drawn with any center and any radius. Fourth postulates. All right angles are equal to one another. All right angles are equal to one another. For these also, no geometrical proofs are required. These are also the basic concepts. These are assumptions specific to geometry, which are obvious universally truth, These assumptions are termed as postulates. Now, fifth postulate. If a straight line falling on two lines makes the interior angles on the same side of it taken together less than the two right angles, then the two straight lines, if produced indefinitely, meet on that side on which the angles are less than two right angles. That is, PR is a straight line, QS is a straight line, AB is a straight line, fall on this. Angle 1 and angle 2 are the interior angles to the same side of the line AB. Now, angle 1 plus angle 2, if it is less than 180 degree, then if RP and SQ are produced to this direction, that is to the direction where the sum of the angles is less than 180 degree, if they are produced to that direction, they will intersect at a point. Say this point is T. We have shown this one as the sum of these two angles, angle 1 and angle 2 is less than 180 degree. So if these are produced to this direction, they will meet at a point according to the postulates, and it is true. We see that it meets, that is, the lines meet at point T. Next, theorem. Theorem. What is a theorem? A statement that requires a proof is called a theorem. A statement that requires a proof is called a theorem. Example: the sum of opposite angles of a cyclic quadrilateral is 180 degree. This is a theorem, and we have to prove this one. Similarly, the sum of angles of a quadrilateral is 180 degree. This is also a theorem because they need to prove this one. Similarly, we can say the sum of all angles of a triangle is equal to 180 degree. So that is also a theorem because we need to prove this one. The angles opposite to equal sides of a triangle are equal. This is also a theorem because a proof is needed. Then what is called a corollary? Corollary means a result deduced from a theorem is called a corollary. Result deduced from a theorem is called a corollary. Now, according to Euclidean concept, we will learn the definition of some geometrical terms like point, line, etc. Point. What is a point? A point is denoted by a fine dot on a paper which has neither length nor breadth nor thickness. That is a point. It does not have any length, any breadth, any thickness. It is represented by a letter P. Alongside, we have drawn a figure. This is the paper. On the piece of paper, there is a point. This indicates the point. This is the point. It is denoted by P. Next, we are going to learn line. What is called a line? when we fold a piece of paper, when we fold a piece of paper, the crease in the paper represent a line. What we see, this is a piece of paper. This piece of paper is folded along this, there is crease AB. Now whenever this paper is folded like this as shown in the figure, it forms a crease AB. This AB is a straight line. Now some axioms of points and lines. A line contains infinitely many points. That is, a line is made up of infinitely many points. When all these points are joined, they form a line. Through a given point, infinitely many lines can be made to pass. Suppose this is a point, from this point we can draw several lines, as many lines as we want. So many lines can be drawn through this point, say Q. Third, given two distinct points, there exists one and only one line through them. Suppose there are two distinct points A and B. So through these 2 points we can draw only one line. More than one line is not possible. So through given two distinct points, there exists one and only one line through them. Now a theorem. Two distinct lines cannot have more than one point in common. It means two straight lines can intersect exactly at one point, not more than one point. How we can prove this one? Let us assume two lines P and Q, and if possible they can intersect more than 2 points. So if they intersect more than 2 points, so through 2 points more than one distinct line can be drawn, which contradict Euclid's axiom that through two distinct points one and only one line can be drawn. So as this assumption contradicts Euclid's axiom, so this is beyond the scope. This is our wrong assumption, so we cannot assume that two straight lines can intersect more than 2 points, more than 1 point in 2 points. Okay, so what we have learned, that is two different distinct straight lines can intersect only at 1 point. Now equivalent version of Euclid's fifth postulates. Now first let us recall what is Euclid's fifth postulates. Euclid's fifth postulates states that if a line falls on two lines, to which side the sum of interior angles to the same side of that line is less than 180 degree, if the lines are produced to that direction, they will intersect at a point. Now there is one equivalent statement version of Euclid's fifth postulates. It is the Playfair's axiom. For every line M and for every point P not lying on the line M, there exists a unique line L passing through the point P and parallel to M. That is, as the P point is not on the line M, through this point we can draw so many straight lines. Out of this, only one line can be parallel to M. Not more than one line can be parallel to this. So there are infinitely many straight lines. There are infinitely many straight lines can be drawn through the point P. But there is exactly one line L which is parallel to the line M. Thus, two intersecting lines cannot be parallel to the same line. So, introduction to this chapter, introduction to Euclid's geometry, what we have learned? We have learned the origin of geometry, how geometry develops gradually till today. Euclid, who is known as the father of geometry, he has given some axioms which needs no proof, then some postulates which are also needed no proof, then theorem. But for the theorems we need some proofs. To prove this one we can take the help of other theorem or the postulates or the axioms. By this we prove the theorems, and at the same time we have learned Euclidean definition of point, Euclidean definition of line, Euclidean definition of two parallel lines. Like two lines are said to be parallel if the sum of interior angles to the same side of the transversal, that is the line which cuts them, is equal to 180 degree, then the lines are parallel to each other. There is, from here we can say that as L and M are parallel, then sum of this angle plus sum of this angle is equal to 180 degree, exactly 180 degree. That is why they are parallel to each other. So students, you are advised, go through the video repeatedly, make notes, point out which point is not clear to you, see the video again, clear the definition, then proceed to the exercise. Okay.